Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about intervals of increase and decrease.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Y equals a negative x to the third power plus 2x squared plus 2, and we gotta find critical points, discontinuities, and intervals here for increasing and decreasing. Now luckily we have a polynomial function right here, and what we know about them is that, well, they're continuous everywhere. And so we can say this one has no discontinuities exist right off the bat. So we have no discontinuities exist right off the bat. All right, now we want to go find where it's increasing and decreasing and find the critical points. And the critical points come first. So to do that, we need to find the derivative of this function. So f prime of x, let's call it here. And we take the derivative, power rule, negative 3x squared, and that's plus a 4x. Okay? From there, we need to solve for x. We set it equal, or solve setting it equal to 0. We're finding when the derivative crosses the x-axis. So we take a negative 3x squared plus a 4x, and we set it equal to 0, and we solve. Pull out an x here. X times a negative 3x plus 4 equals 0. And x, well, we set this one, each part equals 0, so x equals 0, got 1. Negative 3x plus 4 equals 0, and that comes out to be x equals a positive 4/3. And so we have two values here, 0 and 4/3, so we make a little chart. 0 and 4/3. And what we're going to do is that we're going to take values, so these are a critical point, 0 and 4/3. And we're going to take values of the derivative that are outside of these ranges, in a sense here, or domains. So let's go pick a value. I picked f prime of negative 1. I plugged negative 1 into f prime, and I got a negative 7. So that value, I really don't care if it's what the value is. I just care if it's positive or negative, and it's negative. And so that means from negative infinity to 0, we're decreasing. This is our first derivative test. Let's go find what f of 1 is, right? 1 is between 0 and 4/3, so f of 1. And that is 1, so that's a positive number, and that's increasing. And again, I'm plugging it into my derivative up here. Let's go f prime of, I chose 10 at first, just to say, hey, I can see where it's going, but we plug it in and we get a negative 260. And again, the value itself doesn't matter, you just care if it's positive or negative, and it's negative, so it's decreasing. So we have decreasing, increasing, decreasing. So we can, basically we have our information here, let's go write it out here now. Our critical points are when x equals 0 and 4/3. And then where is this function increasing? Well, it's increasing, I'm going to do shorthand here, increasing from our interval from 0 to 4/3. Okay, the interval from 0 to 4/3, we put parentheses around them for our intervals, don't put brackets. It's decreasing on our interval from negative infinity to 0, and from 4/3 to positive infinity. And so there is our final answer for this function. No discontinuities exist. Our critical points are 0 and 4/3. We're increasing from 0 to 4/3, and we're decreasing from negative infinity to 0 and 4/3 to positive infinity. We're given this problem right here. Y equals x to the third power minus 11x squared plus 39x minus 47. We're going to find critical point, discontinuities, any interval where it's increasing or decreasing. So, first thing I want to notice here is this is a polynomial function, right? And so what we know about them is that they're continuous everywhere, all domain. So, this one actually right off the bat, we can say that no discontinuities exist. Okay, no discontinuities exist. We got that off the bat right here. All right, to find our critical points, we need to take the derivative first. So let's go find f prime of x here, and we're going to use our power rule here. 3 comes down, 3x squared, minus 2 times 11 is 22x. And then we just have a plus 39. Hopefully you're good at derivatives here. From there, we set that derivative equal to 0, and we have to solve for x. 3x squared minus 22x plus 39 equals 0. And let's solve. Now, this factors out to be an x minus a 3 and a 3x minus a 13. It's equal to 0. Solve each part, so we set them equal to 0. X minus 3 equals 0, and 3x minus 13 equals 0. Solving, we have x equals a positive 3, and this one becomes x equals 13 over 3 as a fraction. So where do we go from here? Well, we make a little chart. This is a chart I like to really make here. I take my two critical values here, okay, two critical values, and I'm writing them from increasing to decreasing. So we have 3 here and a 13 over 3. And actually, while we're at it here, let's mention this point. Our critical points at x equals 3 and they're almost over 11. 13 over 3. Okay. So now we gotta find where they're increasing and decreasing. Well, what we want to do is pick a value sandwiched between these two interval numbers here, the critical points, and then below it and above it. And we need to, sorry, my dog's barking here. And we need to plug them into our derivative here. So f prime here, and I'm going to pick an easy one. And I believe I picked, f prime of 0. So I found f prime of 0, and that came out to be a positive 39. And so since it's positive, that's the only thing I care about it. From negative infinity to 3, we're increasing. Now for interval between 3 and 13 over 3, I picked f prime of 4, and it's equal to negative 1. And so f prime of 4 is equal to negative 1. That's a negative number. That's decreasing. Now I need to find something that's larger than 13 over 3. I picked, what did I pick? 10, I believe, yeah. F prime of 10. And that's equal to a positive 119. I can plug it into my derivative. But either way, it's positive, so we're increasing here. And now this gives us a cheat sheet where it's increasing and decreasing. So we're increasing on the interval from negative infinity to positive 3, and from 13 over 3 to positive infinity. We are decreasing on the interval from 3 to positive 13 over 3, and again, we need parentheses here for that. And so that's it. We answered all the questions, and so our final answer here is just no discontinuities exist. Critical points are at 3 and 13 over 3, and our increasing interval is negative infinity to 3 and 13 over 3 to positive infinity, and we're decreasing from 3 to 13 over 3. We're given this problem right here. Y equals a negative x to the 4th power plus 3x squared minus 3. And we got to find the critical points where it's all the discontinuities function and where the function's increasing and increasing. Yeah. Well, luckily for us, right off the bat, we have a basic polynomial function. And so what that tells us is that we're continuous everywhere. So no discontinuities exist. We can get that right off the bat here. Now to find our critical points, we need to find first the derivative. So we find f prime of x here, and it's equal to negative x to the 3rd, I got ahead of myself here. Power rule, I didn't bring down the 4. Power rule, bring down the 4, negative 4x to the 3rd power, plus 2 times 3 is 6, x right there. All right, now from there we need to solve for x by setting this whole function equal to 0. So negative 4x to the 3rd plus 6x equals 0. And then from there we're solving. So I first plotted x here, and I have x times a negative 4x squared plus 6 equals 0. Now we can set both parts equal to 0. X equals 0, got 1, and negative 4x squared plus 6 also equals 0. And now we're solving here. Now subtract a 6 to both sides. We have negative 4x squared equals a negative 6. Divide both sides by negative 4. And x squared equals a positive, let's keep it at 6/4. I take the square root of both sides here. Make sure it's plus and minus. Make that a minus or a plus here. This one's a minus. And so we have x equals the square root of 6/4 plus or minus comes out to be the square root of 6 over 2. and it's negative square root of 6 over 2. That's your plus and minus here. Okay, so we actually have three values, three critical points here. So we can write it out here, critical points. Our critical points are at x equals, let's go in order from least to greatest, negative square root of 6 over 2, that's 0, and square root of 6 over 2. All right. So now we need to make this little chart thing, okay? And I have values here, 0, there we go. Negative square root of 6 over 2 for each one of our critical points, 0, and square root of 6 over 2. It's important to go from increasing to decreasing here. There's 4 blank areas here, and we have to find a value, all right, next value that goes in each one of these things, and plug it into our derivative. So I found them for you. I used first f prime of 10, or negative 10, sorry, and that came out to be 3,940 if I can read my handwriting. And that's a positive number. That tells us, this first derivative test, tells us that positive number means we're increasing our function on an interval. The next one I found was f prime of a negative 1, and that fits within this interval right here, and that came out to be a negative 2, and so it's a negative number, that's all I care about it, and it's decreasing. To the same thing between 0 and square root of 6 over 2, and I found the f prime of 1, and f prime of 1 came out to be 2, which is a positive number, therefore making this interval increasing. And then lastly, we'll go higher on the interval. F prime, I picked positive 10, and that equals a negative 3,940, but it doesn't really matter what the number is, it's that it's negative. And so we are decreasing here. And again, all these values are plugged into our derivative. So this chart now tells me where my function is increasing and decreasing. So we are increasing on our interval from negative infinity to negative square root of 6 over 2, and from 0, if I can write with this marker here, square root of 6 over 2. We are decreasing on the interval, all right, from negative square root of 6 over 2 to 0, and from square root of 6 over 2 to positive infinity right there. And so again, our final answer here for this function is no discontinuities exist. Our critical points are at x equals negative square root of 6 over 2, 0, and square root of 6 over 2. We're increasing on our interval from negative infinity to negative square root of 6 over 2, and from 0 to square root of 6 over 2. And we're decreasing from the interval from negative 6 over square root of 6 over 2 minus, and 0, and square root of 6 over 2 to positive infinity. We're given this problem right here. Y equals x squared over 4x plus 4, and we're going to find the critical points, discontinuities, and the intervals where the function is increasing and decreasing. Well, first thing I notice, this is a rational function. So a rational function, we know we can't divide by 0 and be discontinuous there. So I take my denominator, 4x plus 4, and I set it equal to 0. Solving for x, 4x equals a negative 4, and x equals a negative 1. And so right off the bat, we have a discontinuity at x equals negative 1. So discontinuity at x equals a negative 1. Got that right off the bat. Well, now let's go find our critical points. So what we're going to do is take our function and find the derivative. Let's take some of the quotient rule here. So f prime of x here. All right, derivative numerator is a 2x multiplied by the denominator, 4x plus 4, minus derivative denominator, 4 times the numerator, x squared. All over denominator, 4x plus 4, all squared. From there, we're going to simplify some things. So we have f prime of x here, numerator multiplied it out. 2x times 4x is an 8x squared. 2x times 4 is an 8x, minus, this is a 4x squared. All over that 4x plus 4, all squared. From there, let's go simplify this a little more. F prime of x here. The numerator gets simplified. 8x squared minus 4x squared is a 4x squared plus 8x over the denominator 4x plus 4 all squared. Okay. Now, one thing we notice here, keeping the denominator, something happens at x equals -1. We're still dividing by 0, but we're aware of that discontinuity and that issue there. We want to find our critical points, so we're going to take our numerator, our 4x squared plus 8x, and we're going to see if this function is equal to 0. Okay? The denominator, if we're dividing by 0, we already found that. That's an issue. Again, like I said, can't use it. So we care about the numerator here. Pull x out. We have x times 4x plus 8 equals 0. Solve x equals 0. 4x plus 8 equals 0. And x equals a positive, or a -2. -2. So now we have to make a little chart with our values here. We're going to make a little chart here. Okay. We go from decreasing to increasing. We have a critical point -2, discontinuity -1. Here, another critical point 0. Oops, I don't need this extra line. I did too many lines. It's alright. Alright. So from here, what we want to do is find where we're increasing and decreasing. That's what this first derivative test will do for us here. So what we want to do is first find an f prime. Let me separate this out here. F prime, I'm going to pick a value that's less than -2, and I picked a -3. When I plugged into my derivative, which right here, plugged into my derivative, I got a 0.1875. Don't really care what the number is, but it's positive. That means our function is increasing on that interval. Same thing, plug into our derivative, f prime of -1 was, -1.5. See, we can't actually pick the critical value or the discontinuity here. We want to pick something in between. So an f prime of -1.5 is a -0.75, and again, we just care about the negative. Negative right there, we're decreasing. Pick a value between -1 and 0, and that I picked was a -0.5. Okay, so f prime, f prime of a -0.5, and it came out to be a -0.75. It's negative, it's decreasing. Okay. Lastly, pick a value bigger than 0. F prime, I picked 1, make it easy, and it came out to be a 0.1875. All I care about is that it's positive, therefore we're increasing. And this gives us our intervals here for our functions increasing and decreasing. We're increasing here from a -infinity, right? -infinity to a -2, and from 0 to positive infinity. We're decreasing here from a -2 to -1. We have a discontinuity there, so we have to make a little break. And then we're decreasing from -1 to 0, and again, parentheses, we're not decreasing at -1. And so our final answer here, I didn't put the critical points down. Oopsie. Forgot that. Critical points were a -2 and 0. X equals a -2 and 0. Almost forgot that. So our final answer here is we have discontinuity at x equals -1, critical points at x equals -2 and 0. We are increasing from -infinity to 2 and from 0 to positive infinity, and we're decreasing from -2 to -1 and -1 to 0. We're given this problem right here. Y equals 3x squared minus 3 over x to the third power, and we got to find the x coordinates of all critical points, find the discontinuities, and the intervals where our function is increasing and decreasing. Now our function here is a rational function. And since it's a rational function, we know it's discontinuous where we're dividing by 0. So we take our denominator x to the third power and we set it equal to 0 and we have to solve. Well, that's easy. Take the third root of both sides. X is by itself and third root of 0 is 0. So right off the bat we found that our function is discontinuous, so we have discontinuity at x equals 0. Pretty simple, right? Now we gotta find the critical points. We need to first take our derivative here. So to do that, we use our quotient rule. We find f prime of x. Derivative of numerator as a 6x here, right? 2 times 3 is a 6. Times our denominator, x to the third power. Subtracted by derivative denominator, we have is a 3x squared times our numerator, 3x squared minus 3. All over that good old denominator squared. All right. From there, let's go simplify this. F prime of x here is equal to 6x times x to the third power is 6x to the fourth power minus, multiply this part out here to both things. 3x squared times 3x squared is a 9x to the fourth power, and it's negative 9x to the fourth power. Negative again gets distributed, but becomes a positive. 3x squared times 3 is a 9x squared, and the two negatives make it positive, so we have 9x squared here. All over our denominator, which is now x to the sixth power. F prime of x here, simplify the numerator, 6x to the fourth minus 9x to the fourth is a negative 3x to the fourth, and you knew that. Plus a 9x squared all over x to the sixth power. All right. Now, of course, if we divide by 0 here, it's the same 0, that kind of issues here going on. But the critical point really happened with our numerator. When is the whole function equal to 0? So we're going to take our function derivative, set it equal to 0. And that really only happens when the numerator is equal to 0. So I'm going to take that 3x to the fourth power plus 9x squared, and I set that equal to 0. From there, we need to, well, solve for x. Pull out an x squared. I have an x squared here times a negative 3x squared plus a 9 equals 0. Okay? Well, let's set both parts equal to 0. X squared equals 0. Negative 3x squared plus 9 equal to 0. Solving. Square root of both sides. X equals plus or minus 0, which is just 0 here. And we have negative 3 and 9. Subtract a 9 divided by negative 3. We have x squared. Comes out to be a positive 3, square root of that, x equals plus or minus square root of 3. Okay. All right, so now the critical point here, our critical point is just going to be that negative square root of 3 and 3 here, because we already had the discontinuity at x equals 0, so our critical point at x equals a negative square root of 3 and a positive square root of 3. Now we have to make a little chart. This is the fun little chart here. We use our discontinuities and our critical points. So we have 3 of them total. Negative square root of 3, put it in order, 0 and positive square root of 3. Now all these values we're plugging in are from our derivative that we found right here. Okay? I'm going to find a value that's less than the square root of a negative square root of 3, and I had to pick negative 5. So I found what f prime of negative 5 was, and that came out to be a negative 0.1056. Don't care what the number really is, but it's negative. That's the only thing apart. Negative, which means we're decreasing with our first derivative test. Now, between negative square root of 3 and 0, I picked negative 1, so I found f prime of negative 1 here. And that came out to be a positive 6. I just care that's positive, and then it's increasing. Same thing between 0 and square root of 3. I found f prime of 1. Positive 1 here, it's within that interval. And again, I got 6, positive, increasing. Now, keep on going. F prime, I want to find a value bigger than square root of 5, so I found f prime of 5, or square root of 3. I found f prime of 5, which is a negative 0.1036. Don't really care what number it is, just that it's negative, and we are decreasing there. Okay, so this tells us all that we need to know. Our intervals where we're increasing happen between negative square root of 3 and 0, and 0 to square root of negative 3. Remember, it's separated because we have discontinuity x equals 0, and it's decreasing here on the intervals from negative infinity to negative square root of 3, and our interval from square root of 3 to positive infinity. And so again, our final answer here is we have a discontinuity at x equals 0. Our critical points are at x equals negative square root of 3 and positive square root of 3. We're increasing from negative square root of 3 to 0, and from 0 to square root of 3. And we're decreasing from negative infinity to negative square root of 3, and from square root of 3 to positive infinity. I'm given the problem right here. Y equals 2x minus 8 all to the 2/3 power, and we got to find the coordinate points, or the critical points, the discontinuities, and the intervals where the function is increasing and decreasing. Well, luckily for us, there's no value for x that we're not allowed to plug in. And so our function is really just continuous here, or this type of function being a third root function here. Basically, you're looking at the 2/3, the third root's the only thing that would maybe cause an issue. But either way, no issue there. We have no discontinuity. So we have no discontinuities exist. All right. Now to find our critical points, we need to take the derivative of our function. So we take f prime, we find f prime of x, using the power and chain rule, 2/3, times the inside, 2x minus 8, subtract the exponent by 1, negative 1/3 here, times the derivative inside, which is 8/2. Okay? Now, simplifying this, we have f prime of x here is equal to 2 times 2 is that 4. Denominator has that 3, and we can bring the 2x minus 8 to the denominator, negative 1/3 power, as a third root right there, positive in the denominator, and 2x minus 8 here. Not too bad. All right, so now we have to find where this function is, well, equal to 0. And the way I'm going to do that here, or find our critical point here, is I'm going to take my denominator and set it equal to 0. Okay, so that's going to be an issue there going on. So I take my denominator and I set it equal to 0, or really the whole derivative, but I only care if the issue happens in the denominator. So I take 3 third root of 2x minus 8, and I set it equal to 0. And now we're going to solve. Well, divide both sides by 3, doesn't really matter. We have the third root of 2x minus 8 equals 0. We cube both sides, doesn't really matter. 2x minus 8 equals 0 cubed is 0. Add an 8 to both sides, 2x equals a positive 8, and x equals a positive 4. Okay? And so we have one critical value, a critical point, at x equals a positive 4 here. Okay? So now we're going to make our little chart just at 4. Okay? So right at 4, something is happening here. And what we want to do is take our derivative, f prime, right there. Okay? And we're going to plug in a value that's less than 4, which is, well, 0 for x. That's what I did. That came out to be a negative 0.6 repeating. I don't care what the number is, I care that it's negative. So this negative, our function is decreasing on that interval. I found a value that was bigger than 4, and I picked 5. So f prime of 5, when I plugged into my derivative, came out to be a 1.0583. Don't really care what the number, only that it's positive, and we're increasing. And so now we have our intervals here. Our function is increasing on the interval from 4 to positive infinity, and we are decreasing on the interval from negative infinity to positive 4. Okay? And so our final answer here is that no discontinuities exist. Our critical point is at x equals 4, or we're increasing from 4 to positive infinity, and we're decreasing from negative infinity to positive 4. We're given this problem right here. Y equals a negative 1/5 times, in parentheses, x minus 4 to the 5/3 power minus 2 times x minus 4 to the 2/3 power minus 1. And we define all the critical points where the function is discontinuous and where the function is increasing and decreasing. Now luckily for us, the only issue we could have is the third root that's going on, the 3 in the denominator, the fraction of the exponent. But third root, we're basically fine. It doesn't limit where we can plug in numbers here, so our function is actually continuous everywhere. So we can state that no discontinuities exist. Alright, so let's go find our critical points. To do that, we have to find the derivative, and this one's a tricky one. So we're going to find f prime of x here. Well, f prime of x, again, we're using our power rule. 5/3 comes down, so we have negative 1/5 times a 5/3 times the inside x minus 4, and subtract the exponent by 1, which is a 2/3 now, and then the exponent, minus 2 times this exponent comes down 2/3 times, oh, I even forgot, oh sorry, just so you know, power rule here, we have 2/3 in the exponent, and then we have to multiply by the derivative of the inside, which is just a 1. I should put that there for you. So again, sorry, 2 here, and then 2/3 comes down, inside x minus 4, to the exponent, 2/3 minus 1 is a negative 1/3, times the derivative inside is just a positive 1. Be careful with that. Alright, so derivative inside is just a 1 there. With that, let's go simplify where we can. We have f prime of x here is equal to 5's cancel. Okay, the 5's cancel there. We have a negative 1/3. So we have a negative out here. 3 is in the denominator. Numerator is still that x minus 4 to the 2/3 power. Minus. Alright, now the right side here. We have a 2 times 2 is a 4 in the numerator. We have a 3 in the denominator. Right there, it's left over. Then we have x minus 4 to the negative 1/3 power is the same as the third root in the denominator of x minus 4. Okay. So now this becomes tricky. We need to combine this to be one fraction here. So to do that, I'm going to take this first part and have a common denominator, just like we do with fractions. So I have a negative x minus 4 to the 2/3 power over 3, and I'm going to multiply this by this second part of this denominator. And to make it easier, it's x minus 4 to the 1/3 power over itself. X minus 4, 1/3 power, minus, keep this part the same, 4 over 3, third root of x minus 4. Alright. From there, keep it tricky. And remember, these are the same here, but I did that because it's a little easier to see this multiplication here. F prime of x here. Well, this is where the beauty comes in. We have a negative stays up front. We have x minus 4 to the 2/3 power. That's a 2/3 power, just so you know. And then x minus 4 to the 1/3 power is all combined. We add the exponent to be the 1 power. So we just have an x minus 4 here. Then the denominator stays the same. It's a 3 third root of an x minus 4, just so you can see that. Same thing. Same as this denominator, so we can subtract that 4 here in that numerator. Keep going, simplifying this. F prime of x is equal to, good old, we have a negative x up front here now, negative x, and then the negative goes to both parts, making this a negative here, and the x positive 4, subtract a 4 is 0. We're done. And we have 3 over third root of x minus 4. Okay, we need to find our critical values here. So the critical values, what we want to do is set really the numerator and denominator both equal to 0. All right, we're going to set the whole function equal to 0, but in doing so, we care more about the numerator equal to 0. And so that first part, numerator, negative x equals 0, and that happens at x equals 0. We got one critical point. Denominator equal to 0. Let me break this down a little here. We have 3 third root of x minus 4 equal to 0. Divide both sides by 3, doesn't really matter. Third root x minus 4 equals 0. Don't matter, we take the third power there. Third power is 0, 0. X minus 4 equals 0. And so x equals a positive 4. So we have our two critical points here. My marker doesn't die on me here. I need markers. Critical points are at x equals 0 and a positive 4. So now we make our handy dandy little chart, which I think I can just fit right here. Make sure it's within my range of my writing. We have 0 and 4. And what we're going to do is find values within these intervals here and plug them into our derivative right there. So I want to find f prime of, I picked a negative 1, and that came out to be a negative 0.1949. Don't care what the number is, I just care that it's negative, meaning my function is decreasing there. Between 0 and 4, I picked 1, f prime of 1, and that came out to be a 0.23112. Don't care what the number is, I care that it's positive, so we're increasing. Then I want to find f prime of, I picked 5, just bigger than 4, and that came out to be a negative 1.6 repeating. Don't care the number, I care that it's negative, and we're decreasing. And so now I have my intervals where we're decreasing and increasing here. I can write them out. We're increasing on our interval from 0, my marker doesn't die in the last little bits here, 0 to 4 is a function where we're increasing and we're decreasing in two parts. Decreasing from a negative infinity to 0 and from 4 to positive infinity. And so again, our final answer here, we have no discontinuities exist. Our critical points are x equals 0 and 4. We're increasing from 0 to 4, and we're decreasing from negative infinity to 0, and from 4 to positive infinity. We're given this critical thinking question. If the functions of f and g are increasing on an interval, show that f plus g is increasing on the same interval. Okay, so what we know here, if f and g are increasing on an interval, we know that if x1, some x value, is less than x2 on our interval, then f of x1 has to be less than f of x2. And I'll say it as well here, g of x1 is also less than g of x2 because they told us our functions were increasing, okay, on some interval. And we're saying the interval is from x1 to x2, let's say. So then if that happens, therefore, we can state, right, if we know that, right, our interval is from if x1 is less than x2, then f of x1 is less than f of x2, and g of x1 is less than g of x2, then since that happens, we know therefore f of x1 plus g of x1 has to be less than f of x2 plus g of x2. I can fit that parenthesis in there, and therefore we just showed that f plus g is increasing on this same interval because the sum of their output, okay, f plus g at x1 is less than f plus g at x2, and so that is our final answer. We're given this critical thinking question. Give an example where functions f and g are increasing on the interval from negative infinity to positive infinity, but where f minus g is decreasing. Okay, let's first start with two functions that are increasing on our interval. And again, there's going to be many answers here. I'm just going to show you a simple one. So let's say example, let's say f, our function f is equal to just x. That is increasing on the interval from negative infinity to positive infinity. What about g? Let's say g is equal to 2x. Again, this interval is increasing from negative infinity to positive infinity. But what happens when we have f minus g? F minus g is equal to x minus 2x. Simplify that, f minus g, x minus 2x is a negative x. Well, negative x, is that decreasing on that same interval? Yes. Our f minus g, we count to be negative x, is decreasing on the interval from negative infinity to positive infinity. So two examples of functions here that satisfy this critical thinking question where functions f and g are increasing on our interval from negative infinity to positive infinity, but are decreasing where f minus g is decreasing, or decreasing where there's f minus g, is example, again, it could be many, but here's just one of them. F is equal to x and g is equal to 2x. I hope this video was helpful for you. And if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you, for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.